Hello, welcome. Let's try to solve another Leetcode problem, 829 consecutive numbers sum. So we are giving a integer n, so we're going to return the number of ways you can write n as the sum of consecutive positive integers. So for example, we have number 5 going to equal to 2 plus 3, and 9 going to plus equal to 4 plus 5, and equal to 2 plus 3 plus 4. And similarly for this n equal to 15, there's going to be 4 result. Yeah, and the value of n going to be 10 to the power of 9. Yeah, so basically we cannot solve it in O(n) time because n is too big. Yeah, and we are also giving it's like a mathematical formula. So because it is a consecutive numbers, so basically we're going to use the mathematical formula to solve the problem. Yeah. Now let's try to analyze it, because basically we need to use the formula to solve the problem. Yeah. Let's start to check. So for number like a1 plus a2 and plus until to ak should equal to this number n. Yeah. And from this, because it is consecutive numbers, and we can use the mathematical formula directly. So it's going to be k times a1 plus k times k minus 1 divided by 2, and should equal to this number n. Yeah, and we have to calculate it. Yeah, but before that we need to analyze, because this is a k times a1, and this a1 should always be more than and equal to 1, right? Because a1 is the first number. It's gonna be starting from 1 or 2 or any other numbers. So this means a1 gonna be more than and equal to 1. Yeah. So this means from this formula we can get some result. Let's just times 2 to the right side. So 2 times k times a1 plus this one. Yeah, k times k minus 1 should equal to let's use 2 times n. Yeah, we just from the left side we're gonna times 2, and the right side we're gonna times 2. Yeah, we just need to check if we can get something from this kind of a formula, because this a1 gonna always be more than and equal to 1. Now we can get a formula. Yeah, so the formula is gonna be 2 times n. Let's check just from the right side. Yeah, so it means 2n should be more than and equal to 2k. So this 2n means 2 times n, 2k means 2 times k. Yeah, should be more than equal to 2k plus k times k minus 1. Yeah, so this is because a1 gonna be more than and equal to 1. So this is the result from a1. So it means this result should be more than, this result is 2 times n, should be more than and equal to 2 times k plus k times k minus 1. Yeah. So if we can get it from here, we are quite close. Yeah, because 2k plus k minus 1 is gonna be k times k plus 1. Yeah, as you can see, we are quite close. So this is the first formula. So let's set it as formula 1. The first formula is going to be 2n should be more than and equal to k times k plus 1. Yeah. So let me just copy it and delete the unused areas. So this is the first formula. So we're going to use this first formula to check the result, because basically we have this value of n, and another value is k. So we can just enumerate this case, because k is just a divisor. Yeah. Now we need to, yeah, because basically this k times k plus 1 yeah, should be less than and equal to 2 times n. And we also need to have another formula. So another formula, let's just use it from here. So 2k times a1 yeah, plus k times k minus 1 should equal to 2n. So we're gonna use this formula because this is also useful. Yeah. So let me copy it. So this is gonna be my formula 2. Yeah, because if we use a more than and an equal, we cannot solve the problem. Because the problem is that we have to let it equal. So this is what we get. So this means 2 times k times a1. Let me make it closer. So it means 2k times a1 plus k times k minus 1 should equal to 2n. Yeah. So this is our second formula. Basically, we're gonna use those two formulas to solve the problem. Yeah. So from here, we know that k times k plus 1 should equal to 2 times n. Yeah. Basically, this means 2n modular k. Yeah. So this means 2n modular k should be an integer. And that value should be smaller. Yeah, if this 2n more than and equal to k times k plus 1, we can further get it. So this means 2n should be more than k times k, or we can make it easier. So 2n should be yeah, because this is more than and equal. If we directly use k, so it's gonna be more than. So it means 2n should be more than k times k. Yeah. So this is still the first formula, and this is the second formula. So we're gonna just enumerate this 2n to check how many possible results meet the formula 1 and the formula 2. Yeah. So for here, we just need to check a number. The square of a number, if the square of a number should be less than 2 times n. Yeah. Now I think we can try to solve it. So for let's just check a result should be equal to 0 and n should equal to 2 times n, and then I'm gonna enumerate all the possible results. Yeah, because this is 2n, so for here 2n equals to n, so here I set it to be n. So I'm just gonna enumerate all the possible values of this k. Yeah, basically I need to check all the possible values of the k. So for I in range from 1 to integer square root of n plus 1, I need to check this number. If n modular my I, let me set it to be k. Yeah, if n modular this k equal to 0, yeah, this means this number is divisible by this number k, and let me just check it. This is gonna be modular k equal to 0. Modular k and also this number should be smaller because k squared should be less than n. Yeah, let's just try to use some examples maybe. For example, if this 2n, let's just set it to be n, maybe 5. Yeah, so if k times k is equal to 2 with 2. So this is a possible result. Yeah, because 2 times 2 it is 4. 4 less than this n. This is just n. Yeah, 4 less than 5. So this is okay. Yeah. So we can also try to use other examples. Maybe k equal to 1. So 1 times 1 it is less than 5, it is okay. This is one possible result, this is another possible result. Yeah. But what about 3? 3 times 3, it is 9. 9 is more than 5, so it should not be okay. So this means while we are enumerate this k should always be a smaller divisor. So this divisor should be smaller than other values. So for example, yeah, let me use 8. So if we find a 2, so 8 divided by 2 is 4. So this 2 should always be less than 4. So if we get a 4 more than 2, so it is not okay. Yeah, because 4 times 4 it is 16, 16 more than 8. And 2 times 2 is 4, 4 less than 8. It should always be okay. So it's all about mathematics. Yeah. So if we can get something like that, basically we can directly solve it from the formula. Now we're going to check if this n divided by k should less than if this n divided by let me just check that. N divided by this is okay. Yeah, let me just use another one. We can use any formula. I think it is okay if n divided by k should be more than this number k. Let's just take it. Yeah, because basically if it is divisible, we can directly calculate it. Yeah, I think any formula is okay if n divided by k is more than n. So this is n modular divided by k should be more than k. Yeah, if it is more than k, it is okay. But currently we cannot get the result. I think it's going to be wrong because we didn't use the second formula. Yeah, because this is just to check if it is more than or equal, and for the second case we have to check the equal. Otherwise we cannot get the result. Let me just check that. Yeah, as you can see, it passed 3 testing cases, but for the testing case 4, it didn't work. And because we didn't consider the second formula, so the second formula going to be 2k times a1 plus k times k minus 1 should be equal to 2n. So currently we just get this number n, we just enumerate this k, so we can directly have another formula check. So we're gonna check it from here. So this means n, so this is n divided by k. Yeah, let me check that. Yeah, so the second formula would be this n divided divided by k. Yeah, I think we have to calculate more about it. So from the right side it is a 2n. Yeah, so I'll set 2n to be n. So n divided by k should equal to k times k minus 1 plus 2 times a1. Yeah, so this is going to be the second formula. We can get it. We can still get it like this. Yeah, because here we're going to use it. Yeah, because this is n. So we're going to use because n is divisible by k, so we can directly use it. Yeah. So we're going to use n divided by k. Yeah, let me just check. N divided by k. This is here should be k minus 1. Yeah, because n divided by k here is 2a1, and this is k minus 1. Yeah, so n divided by k should minus k minus 1. So the minus k minus 1. Yeah, so this is the result. So for this result should be modular 2, because this is a 2a1, because this basically, if a1 equals to 1 or 2, yeah, n divided by k, so this is a 2a1. Yeah, we just need to get the formula. So minus k minus 1 should be equal to should be equal to 2a1. I think this one minus this one modular 2. Yeah, I did it. I must did something wrong. This is n divided by n divided by k, and this is k minus 1, and this is 2a1. N divided by k minus k minus 1 should be equal to should be equal to 2a1. Basically, this means this is a even number, no matter a1 equals to 1, 2, or 3. So this is a even number. So it means if it is a modular 2, because it is even number, it's gonna be 0. Yeah. Now let me just run it to check. As you can see, it works. Yeah. But we have to solve it like this. Basically, it's all about mathematical formula. Although we know about here, and we need to deduct it like this, and we're gonna check the final result. Basically, this formula, and we're gonna use n divided by k minus k minus 1, because it is an even number. So we're gonna use modular 2 equal to 0, and from this number 2n more than k times k, basically. Yeah, we need to check if it is modular k, if n modular k equal to 0, and if n divided by k more than k. This is we directly get it from here. But why we use n modular k equal to 0 to check? This is n. Yeah, because it is always to be integers, n to be integer, and this k is also integer. Because we need to get the divisors. If we were to get the divisors, basically we need to check n divided by k to get the possible result. It's just like we're gonna enumerate all the possible results. So before that, we have to check if this is n is modular k equal to 0, and then we're gonna check all its divisors. Yeah, so I will stop about it here. Basically, I don't think I explained